Yeah, hello. How are you today? Uh, Welcome to my channel again. So today we want to discuss on how to detect droughts, areas with severity of droughts. In your study area. So when you talk about droughts, it affects so many things. When you talk about drought, accessibility to water, it can be difficult. Farmers, agricultural personnel, they may find it difficult to to produce farm products, and then this can come down to drought of food and all that, and which can escalate into epidemics and all that. Because of drought. So you can have a situation where you want to know area that are severe when it comes to droughts, drought severity within a region, a country, or a state, or a location, of interest to you. So today we are going to see how we're going to run a drought severity index. I think I have it saved somewhere here. So there's a script. So the first thing is for you to collect your uh, what's called your drought data, and this is the data here. Idaho EPS COR. So you can go just to look at it, copy it. So let's go and look at the characteristics of it. So there is it. It's a Terra climate. So that's the name of the what's called of the data. The data is a Terra climate monthly climate and climatic water balance for global terrestrial surface. So let's look at it. So there is it. Terra climate. That's the name of the data. Monthly climate and climatic water balance. So looking at the water balance. Data availability. Data availability 1958-01. So data has been available since 1958. And this is the collection SNPnet. That's all the same thing we have here. Sorry, let me see if we can move this. I can't move it. I can't move it. This is the SNPnet. So see example. Close this. Sorry. There is a SNPnet. This one will just show us example of how it looks like, and all that. So let's see it. Let's see the example. There is it. There is it. So let's see if we run it. Let's see what happens. Okay, so exactly what we got all the time. That's from so this one is giving us temperature, minimum temperature, maximum temperature, and the rest. So close it. So we're going to what the tags. We have climate, drought, evapotranspiration, geophysical, global. Now the description. Now Terra climate is a data set of monthly climate and climatic water balance for global terrestrial surface. It uses climatically aided interpolation, combination of high spatial resolution climatological normals from world climate data set. So You can read about it, distribution of this data. You can read about it here. Then look at the bands. You have the AET bands as actual evapotranspiration derived, actual evapotranspiration derived using one-dimensional soil-water balance, minimum, maximum units in the scale. We have the climate DEF, which is the climate water deficient, derived using one. You have the characteristics. Now here, since we're looking at the drought index, so we're going to be using this one, PDSI, Palmer Drought Index, Severity Index. The minimum globally, the minimum is value is minus 4317, and the maximum is 3418, and the scale is at 0.01. So if you are looking at evapotranspiration, if you want to map evapotranspiration, this data set is still useful for you. Only you are going to use this this data, this band. You're going to use this band. You are going to use the AET band. So AET band is useful for if you are mapping actual evapotranspiration. This band is useful if you are mapping climatic water deficits. If you are mapping climatic water deficit, you use this band. If you are mapping drought severity, use this band, that's PDSI, Palmer Drought Severity Index. If you are mapping PET, that's reference and evapotranspiration, you use this band. If you are mapping precipitation accumulation, you use this band. So they are different. If you want to map runoff, derived using one-dimensional soil-water balance, you use this band for such. So you have so many bands there where you can use for different analysis based on their functionalities. So that's that. Image properties, string, time of use. You have the time of use here. You have the citation. If you are using this data, you don't just run the map with it, and you have to the provider of this data, they say that you have to cite, put them in the reference, put them in the reference of your map. So you have to put a reference of where you got your data from when you're mapping it and all that. So if you are mapping this using this data, since we are going to use this data set, that's Terra Climate, you can just import. But for me, I have imported it already. This is it, so I don't need to import again. Now to define our area of study, for me, I'm defining Nigeria, which I've added to the Google Earth Engine interface. There's a way you can add your shapefile. This is a shapefile of Nigeria at Nigeria as an administration data. So I added it, and I call it my ROI, which is the region of interest. I have videos, to show how to add that shows how to add your shapefile into your Google Earth Engine interface, so that you can use it as your AOI, that's area of interest, or ROI, the way you call it, region of interest, for your delineation of your mapping area. So that's that. So now this is a function. We call up the data set. This is the data set. This data set contains all the bands that we showed in the last just some few seconds, minutes ago. This data set contains all the bands. Now here we are filtering the date. We want, from the information we got from here. When we open this, we saw that from here we saw that the data availability of the data has been since 1958 till present. We still have the data till now, but since 1958 we have the data. So here we want to say, we are now saying, now we see we have data of 1958 to 2025, which is still continuously working. Then, but we need just data of 2021. We need data of just 2021. So we have to filter from the pool of data that's for the number of years that the data have been available. We have to filter out the data the year we want. If you want, you can filter out any year. You can filter it out to 1958. If you want to see the changes, difference, you can run for 1958 or 1960 or 1970 something or 1980s. You can run this same analysis for a particular study area or area of interest in for maybe the past year, and then you can run again for the present year, so that you can see what has changed over the time. So that's that. So here we are looking at just 2021. We are looking at data of 2021. This data set within this of 2021, we want to streamline our data search to just 2021. So how to do that? You say dot filter. You use a filter function. Dot filter. Now this is it. Then the date 2021. That's 1st of January. We want our data from 1st of January 2021 and 31st of December 2021. So here you can change the date based on the date that is of interest to you. Then here we now select. Here we filter, because there are pools of data from the day, the starting day, or the starting year that the provider of this data started producing this data till the present year. So we have thousands of data, or like that within the data pool. So we filter for just that. We just look out. We have this function is just for it's just like a search and filter out, bring out only data for this period. Then here I showed you the other time that we have different bands which can be used for different analysis based on the functionalities of these bands. Now, but this is the band PDSI that talks about, which is the Drought Severity Index, that gives us data on severity index. So what we are going to do is we select this band. We don't filter, because it's not like a pool of different layers of data set. Now within this data set of this year, then select this band. Select this band PDSI, which is the Drought Severity Index. Now here, what we do is here the filter here selects from 2021, that's 1st January 2021 to 31st December 2021. It selects every data within 2021. Here now say calculate the mean PDSI for year 2021. We want to calculate the mean, so we need just one data set. We don't need the whole data from January to December 2021. We just need one data set in 2021. Then we calculate the mean. We cannot, and if we want one data set, we cannot just say pick. We cannot just randomly pick one data. No, it will be unfair to the pool of data that we have, and we may have an erroneous result at the end of the day. Instead of picking just one data, maybe from from anywhere, we can just say we can take a mean of the pool of data. Then we say calculate mean PDSI for 2021. That's the function var mean PDSI equals dataset dot mean. Now you see that this dataset that is called there, from this dataset, var dataset is all this the data itself, the filter function that has been put into it, and the selection of this Drought severity index band all this function is the data set. So it's like the data set encompasses all this. So whenever you call data set anywhere in this script, you are calling up all this you are calling up. Instead of bringing all this down, you summarize it to be called data set. So here we have to calculate the mean var data set. So we are calling all this, we said all this, the mean var mean PDSI. That means all this equals to data set, all this dot mean. Then we clip the arrow high, which is this arrow high. We said take the mean. So this function says take the mean of the data set and clip the region of interest. We don't, because this data is a global data, but we don't need the global data. We need just for our own area of interest. That's our region of interest, ROI, which we have defined that our ROI is Nigeria admin, which is a shapefile which has been uploaded into the Google Earth Engine interface. So we now say var mean PDSI equals this data set dot mean. That means find the mean of this data set and also clip our ROI, clip our area of interest. Then here we say define visual parameters var PDSI. That's this PDSI visual minimum -10, maximum 10. Palette red, white, blue. You can use any color combination for you that you want. There is no universal accepted color combination. You can use the color combination that you want for your palette. Now here we say this function says display mean PDSI on the map. So if we don't include this function, we won't be able to visualize our map. It will be like it is working on the ground. The analysis is running on the ground, but we wouldn't be able to see it on our computer interface, on the interface of our Google Earth Engine. We won't see anything, but it is there on the ground. It will be like abstract at this time, but you want to see all your activities, all you are doing, all the functions you are putting up together. You want to see the result on the Google Earth interface, engine interface. We want to see how it looks like. So that's how we put up this display function. Say display the mean PDSI on the map. So the function is map.centerObject. You call your ROI, which is your Nigeria from here. Via ROI is this Nigerian shapefile, and you set it into 2. You can set it. 2 is not a general. There is no general acceptable or accepted figure. You can put 10. You can put 6. Depends on how you want to visualize it. This one it's like a scale. Let me put it like that. How you want to visualize it. So you can put. I decided to put 2. You can put 10. You can put 5. You can put 15. Just the way you want it to look like. You want to visualize it at the end of the day. So then I say Now this one is just to center it, but it's not coming on. To center, you want it instead of coming, since we are working in Nigeria, but the default page when you open your GE shows America, United States, but we are working somewhere on Nigeria. We are working on Nigeria here. So this function brings automatically when you run it. This function states that map.center object to your ROI. So automatically the interface which you are working on, which is Nigeria in this case, will come on your Google engine interface. It will change from United States to zoom or pan to Nigeria region of Nigeria. So at the end of the day, we have this, then we have map.addLayer. So we said add the layer we want to see. Do you remember that the function is display the mean PDSI on the map? This function, the first function here, the center object function, is to shift away from wherever you are, or wherever is popping up, which part of the world is popping up on your Google Earth interface, to your area of interest. So you shift the visualization to your area of interest automatically. Then this map.addLayer, shows, it indicates that you want this layer, after bringing it to your after shifting the interface to your region of interest, also add the layer that we are mapping, add it into my add it. So you say map.addLayer, then you say mean PDVS, which is this. You said add this dataset mean and clip to arrow high. PDVS visualization, add your clip, add your mean PDSI, which is this function. So this stipulates that instead of writing all this function out, you have automatically equate it to this mean PDSI, which is you represent this function. So you don't need to write all this function again. You just write this mean PDSI, comma. That means you are saying what you want to display, you want to display this, and you want to add these visualization parameters to it, and you call it name PDSI 2021, mean PDSI 2021. Sorry. So you are adding this function, and you are adding this function, and the combination with the function, you want to call it this. Then this is the export. If you want to export as export the image to your Google Drive, you export it to your Google Drive. You can download it from your Google Drive, then bring it on your GIS software interface, maybe your standalone or your online GIS interface, maybe your your ArcGIS, or your QGIS. You bring it on it, then you make a map of it from there. So the scale, you say export image dot to drive. This is a function. Then image, what is the name of the image? Mean PDSI. Description, mean PDSI 2021. Scale 500. Region, arrow high. That's our region of interest. Max. So now let's run it. You see, because we put it at 2, you see at the level at which it's run. So let me put it at 10. You understand the difference here. So run again. This is at 10, but still it's running for Nigeria. This is the same thing we'll get at 2, and the same thing we'll get at 10. But at 10 it comes smaller. That's why I related it to scale of the map. At 10 the map looks smaller, but you can still zoom it if you like. I mean at 2 it looks smaller, but you can still zoom it, and at 10 you can still you can what is it called? At 10 it becomes bigger and larger. So this is your severity index. So in 2021 here we have it's where the severity was less in the blue areas. That's drought, and you see in the bright of in the Gulf coastal area around this axis, severity was fair, but in general we have high severity. So that is that. In the next that is that. So if you want to, with this you were able to see which area will have more drought. See the palette. Red, white and blue. The white is just, if you look at the fringes of the blue, you see the white there. The whites are there. So, and then the red, that means that that means the drought severity index in Nigeria in 2021 was very high. So thank you for watching our video today. Then on the task, you can, when you come to the task will start blinking. Then you can come, you see it, you can run. When you run it, it downloads into your Google Drive, and from your Google Drive you can download the image, then put it on your GIS software, and from there you can make your map. So thank you for watching, and God bless. We'll see you next time.